In the final lesson for this unit, we are going to put everything that we've learned so far all together. So far, you've learned about the Pythagorean theorem as well as primary trig ratios. So it's important to recognize when you can use each and also to remember when to solve for lengths and when to solve for angles, and also how to set up contextual problems, so drawing a picture that goes with a description and then solving for the unknown information. So, some things to remember. If you are given a right triangle and you know two of the sides and you need to solve for the third side, you can use the Pythagorean theorem. So remember, Pythagorean theorem only allows you to solve for sides, and that is using a squared plus b squared equals c squared. So that's the Pythagorean theorem. If you were given two sides and you need an angle, or you're given one side and one angle and need to solve for a side, then you're going to use primary trig ratio. So remember, that's sine equals opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent, so SOHCAHTOA. So depending on what information you're given and what information you're asked to find, you are going to use either Pythagorean or primary trig ratios. So if we look at example 1, it's asking you to determine the perimeter of this triangle to the nearest meter. So when you look at this triangle and we're going to find the perimeter, you'll notice that you're given two sides. But in order to find the perimeter, we need to know all three sides. So what we're looking for is this third side. You're given two of the sides and you're looking for the third side. That means that you're going to be using Pythagorean theorem. So in this case, remember in Pythagorean theorem, we have the hypotenuse and the two legs. So here, because I know the hypotenuse, and I'm solving for a leg, I'm going to use a modified version of the Pythagorean theorem. So this is C, and then these are sides A and B. Doesn't matter which side is which. We'll call this one, I'm going to rename it. Instead of calling it X, I'm going to call it A, and this side B. So I'm going to take C squared and subtract b squared to solve for a squared. And I use that version of the formula because I know the hypotenuse and I'm looking to solve for one of the legs. So in this case, 12 squared minus 8.9 squared is equal to a squared. And when you do 12 squared minus 8.9 squared in your calculator, you're left with 64.79 is equal to a squared. So then remember, the final step is to square root both sides. So the square root of 64.79 is equal to a. And the square root of 64.79 is 8.04, so 8, and in this case, meters. Now the important thing when you're working with this kind of problem is to make sure you've actually answered the question that's being asked. So here, I solved for this side, but the question asked for the perimeter of the triangle. And remember, perimeter is the total when you add up the three sides. So the perimeter is equal to 12 plus 8.9 plus 8, which is a total of 28.9 meters. So that would be the final answer. If we look at example 2, it says you are a block away from a skyscraper that is 780 feet tall. Your friend is standing between the skyscraper and yourself. The angle of elevation from your position to the top of the skyscraper is 42 degrees, and the angle of elevation from your friend's position to the top of the skyscraper is 71 degrees. To the nearest foot, how far are you from your friend? So you can see here that in the diagram, you've got you standing here, looking up towards this skyscraper at an angle of 42 degrees, and your friend is standing closer to it at an angle of 71 degrees to the top of the skyscraper. It's asking you to determine how far you and your friend are away from each other. So we're looking for this length here. Now, these 2 points are forming a triangle with the height of the skyscraper. So if we look at how far you are from the base of the skyscraper, that forms one right angle triangle, and your friend, that forms another right angle triangle. So if we solved for the length or the distance from you to the bottom of the skyscraper, and then the distance from your friend to the bottom of the skyscraper, we could then subtract those distances to be left with this distance here. So I'm going to start by labeling my sides. I've got the angle of 42 degrees, and I know that this side is 780. That is the opposite. And I'm looking for the total distance from you to the bottom of the skyscraper. That side is the adjacent side. So I know here with opposite and adjacent, I'm going to be working with tan. So tan of 42 degrees is equal to the opposite over the adjacent. So 780 over the adjacent, and I'm going to call that x. So x is the total distance from you to the bottom of the skyscraper. If you recall from the third lesson in this unit, when we're solving for sides, what you're going to do is you're going to multiply the left side by x and then divide by tan 42. So these two are switching positions. So x is equal to 780 over tan 42. And when you do that in your calculator, you get a distance of 866 feet. So that's the distance from you to the bottom of the skyscraper. Now, if I find the distance from your friend to the bottom of the skyscraper, let's call that y, I can then subtract those amounts to figure out this distance. So the nice part about this is that, again, we are working with the adjacent and the opposite. So tan of 71 is equal to opposite over adjacent. In this case, this is a shorter distance. We're going to switch these two again, so multiply the left by y and then divide by tan 71. So y is equal to 780 over tan of 71. And when you do that in the calculator, the result is 269 feet. So that's the distance from your friend to the base of the skyscraper. Now, if we want to know this distance here, we're going to take this longer distance, 866, and subtract this shorter distance, and it will leave us with this remaining distance between you and your friend. So 866 minus 269 leaves us with a total of 597 feet. So you can see in this question, it's definitely a lot more steps, but we're still just using the primary trig ratio. So we're using everything you've learned so far, we're just putting it together. Let's look at the next example. Example 3 says Stephanie wants to check if the top of a side table is rectangular. She measured the dimensions of the table. Is it perfectly rectangular? So in this case, if it's perfectly rectangular, it means that this angle should be 90 degrees. And in order to check if that angle is 90 degrees, we would need to use Pythagorean theorem. In this case, we are only given side lengths. So what we're going to do is we're going to see if 7.5 squared plus 15 squared is equal to 17 squared. And if they are in fact equal, it means that we have a right triangle. So here, remember in Pythagorean theorem, we label our legs A and B, and our hypotenuse is C, and A squared plus B squared should equal C squared. That would make this a perfect rectangle. So 7.5 squared plus 15 squared should be equal to 17 squared. In this case, when you do 7.5 squared plus 15 squared, the result is 281.25. And we want to know if that is equal to 17 squared, which is 289. So at this point, you can see that these two sides are not equal. So if this was a perfect rectangle and this was a 90-degree angle, these two sides would be equal, but they are not equal. So this means this is not perfectly rectangular. Because it is not a 90-degree angle. And finally, in example 4, it asks us to use the diagram below to determine the distance across this suspension bridge. So, if you look here, this suspension bridge has a series of support wires or cables that are all forming a 32-degree angle with the bridge, and these towers in the middle are 52 feet tall. So it's asking us to find the total distance across this bridge. So remember that so far the primary trig ratios and Pythagorean theorem both require us to have a 90-degree or right-angled triangle. So that means that we need to look at just these small triangles here. This is all that we're going to be able to work with. And we've got a whole series of them, and the nice thing is that they are all exactly the same. They all have this height of 52 and this angle of 32 degrees. So if I solve for this length here at the bottom, let's call it x, then I would know that this is length x, this would also be x, this would be x, and all of these other distances would be the same. So if I just solve for one triangle to get that distance, I can then add them up or multiply to get the total distance all the way across. So using this triangle here, I'm going to start by labeling my sides. I've got an angle of 32 degrees, and I've got the opposite and the adjacent. So that means I'm going to be using tan. So in this case, tan of 32 degrees is equal to opposite over adjacent. And in order to solve for that side, I'm going to multiply this side by x and divide this side by tan 32. So 52 divided by tan 32. And it gives me a distance of 83.22 feet. And you can see here, if this is 83.22, this will also be 83.22, this will be 83.22, and there are 6 distances that are all the same. So the total distance, or the total, yeah, we'll call it distance, will be equal to 83.22 times 6, which is 499.30 feet. It's the total distance across this bridge.